Humans are born helpless. Our upright stance and relatively small birth canal have pretty much ensured that we're born with a brain that's only about 1/3 of its adult size. The human brain weighs about 3 ounces at 6 months. It goes up to somewhere between 13 and 16 ounces at birth. It doubles in weight during the first year after birth, and then it takes about 16 years to add the 3rd pound of brain that a mature brain has. The principle is this: you make all of the cells that a brain needs by birth, and then essentially during this first year after birth, a lot of this is a cerebellum in the back of your head, where your brain basically wires itself up to its body. So the muscular systems, your arms and your legs, basically come online during that particular period. And then during childhood and adolescence, you essentially wire yourself up to the neighborhood. You learn the local language, and you learn the skills and all of these things that a person has to have. The principle is a principle that mothers have applauded over the millennia, and that is, don't make the brain any bigger at birth than you absolutely have to. All right, now, what happened then to having this very, very immature brain simply ensured that we would become a social species. What happened is there was a nurturing commitment that goes maybe 10 to 15 years, and out of that then, that need simply to rear the child in a way that in other animals don't have to worry about. Within a couple of weeks they're ready to go. So this long, long commitment that we had simply ensured then that family units would emerge and social systems would emerge, communities. And so it does basically take a whole community to raise a child. And so that out of this then, in terms of the needs of a human brain as compared to the needs of what we would call a solitary species, animals pretty much that live by themselves and take care of their own problems, is that under these circumstances, if you have a whole bunch of people involved in this, you can begin then to distribute knowledge. In other words, everybody has to know the local language, but not everybody has to know how to repair a car. So, and that's a really important phenomenon. And if you're a solitary species, you have to be able to do everything. See? We don't have to be able to do everything. So the concept then of social knowledge, sort of the knowledge and the skills that you have to have in order to function effectively in a very, very complicated society, led then to what is called a modular brain. And a modular brain means that you have all kinds of very, very specific systems that are designed to carry out very, very specific things like language and all sorts of other things. And it isn't just a whole brain that we have up here, but rather small systems of brains, each of which is maybe stupid by itself. In other words, it can't do anything, but it is a combination then of these individual elements, none of which has intelligence that makes then an intelligent brain. You could think of an ant. When you look at one ant, it doesn't look like it seems to know what it's doing. It wanders around and seemingly in no logical pattern at all. But if you see a bunch of ants moving food from a source back to the anthill, you can begin then to see a little logic in the system and why they're moving the way it's moving. And then when you see the whole anthill, see there's a kind of an inherent logic in an anthill or a beehive that is the combination of everything. And not everybody does the same thing. You have the workers and the drones and things like that. And in your brain, you pretty much have the same thing, is that you have some areas that deal with language and some that deal with movement and some that deal with this and some that deal with that. And so the idea then of a modular brain and the idea of what's called multiple intelligences, that our brain is designed to carry out a number of different functions, means that in a social species, not everybody has to be good at everything. Because we build on the strengths of other people, and other people will shore up our own weaknesses. So that's a really important concept about our brain. And so that many of our brain functions then are simply defined by the social nature of human beings. Among these would be language. See, language is a social phenomenon. Outside of a social species, why would you need language? See, if you don't have any to communicate with other people, there's no need for this. And then there's all sorts of social skills that people have to develop to learn how to read other people's intentions, be able to read their face, to be able to read their movement patterns. See, and all of these things then suggest that in many ways that what human beings have to be able to do, one of the key things that they have to be able to do is to function effectively within social systems. Marion Diamond and a number of other researchers, there's actually quite a literature of this, have studied the effect of a brain in various kind of social systems. Much of this research was done with rats who, they're not humans, but in many respects they're a lot like us in terms of their brain development. And they reared rats in different kinds of environments. And what they discovered over a 25 or 30 year period in studying the development of rats' brains is that when you reared rats in what you call a natural environment, in other words, an environment in which they dealt with the kind of rat problems that rats have to deal with. See, moving around, getting food, if you put them into that kind of an environment, interacting with other rats, is that they develop then what would be called an optimum rat brain. And it would be characterized by the thickness of the cortex, the top layer of the brain, and their ability to carry out various what we call rat functions. But they also discovered that if they took these rats and placed them into a laboratory environment, not an outside environment, but put them into a laboratory environment in which there were analogs of the external world. Rather than climbing around on shrubs, they climbed around on little balls and boxes and things like that and ran on wheels. But there were other rats in the same kind of an environment. It was similar to the external environment, but wasn't identical, is that their brains developed not quite as good as in the outside world, but actually not all that bad. So we can begin to think of that this was kind of like a school environment. See, it was a smaller environment where you created the world out of, it was a sort of a technological world rather than the natural world. And although it's not as good as being reared in the natural world, it really wasn't all that bad. But whenever they reared rats in an environment, it was a solitary environment, in other words, where they had no other rats to interact with, even though they had a lot of toys to play with and they could run on wheels and do all of these things, there was a significant drop in their ability to function effectively as rats and to carry out things. It showed up in their ability to run mazes, it showed up in the thickness of their cortex. And so the fact of the matter is that if you have any kind of solitary species like this, is that the social development of this, of a brain then becomes highly significant. Now, if we take a look at our brain then, that we begin to realize then that social stimulation, see, and challenge, natural social stimulation, natural challenge, and a lot of novelty in the environment creates then the best kind of a brain. Now, so we ask ourselves then about a growing brain, a child's brain, is how does a child spend its time? See, what is a child doing in that first 18 years when a brain is developed? If we take a look at the time and energy that a child spends during the years from 2 to 18, and take like an average day in a child's life, considering weekends and everything else, there's some evidence that this is about a sort of a best fit look at the way a child spends an average day. 8 hours on an average day is spent in sleeping and dreaming. We basically sleep away about 1/3 of our life. Now, this is really important, actually, because many of the activities that happen during the day are consolidated into long-term memories at night. And the reason you have to do this is when you create a long-term memory, you essentially have to kind of like shut down the system for a while because you're physically rebuilding synapses. And so you have the same kind of problem that a highway department has when they're resurfacing highways. You have to get the traffic off of the highway while the cement is being laid down. And in your brain, you basically have to you don't shut it off, but you shut it down. It goes into idling speed. And so you shut off or shut down the incoming sensory information and the outgoing motor information for 8 hours or so. And then that gives you your brain a period of time then to actually get rid of old telephone numbers and put in new ones and put a mustache on the face of somebody you hadn't seen 10 years. And so all of the editing processes that go on apparently go on at night. And then about 2 hours of the time that we sleep at night is spent in dreaming. And there is some belief that essentially what that is circuit testing. So that what your brain is doing during that period is trying out these new memories and checking them out and all of those sorts of things. So that leaves us with about 16 hours of waking time on an average day if you take a child. And these are involved in the development. About 10 of these hours, or we could say 2/3 of our waking time, is spent in interacting directly and informally with family and friends and spending time alone. You're developing personal memories here. In other words, you're exploring the world and trying to figure out what's going on there. These very informal relationships that we have with friends. And so you're creating a sort of the personal memories that define who you are. And about 1/3 of your waking time then is spent in interacting informally and formally with our larger culture. So you're developing here cultural memories, the things that the larger society says that you ought to learn. So that a child by himself interacting with his friends may see no need at all for mastering the multiplication tables. See? But society says, if the society says that mastering the multiplication tables is important, see, then you have to create some kind of mechanism to help kids discover things that they had no way of knowing otherwise. And so that if we take a look then at this sort of 6 hours every day on an average day that we spend in interacting with our larger culture, not the immediate culture of family and friends, that about 4 of those hours are spent in mass media. And that would be like books and songs and radio. And today, in the last few years, of course, is this large influx of electronic information, of television and internet and computer games and video games and all of these sorts of things. We spend about 4 hours, a child will spend about 4 hours on an average day doing that, and 2 hours a day in school. That's about what it averages out over, considering weekends and summers and all of that. So out of the 24 hours a day, our culture basically gets 2 hours to decide and tell children, these are the things that you ought to learn. The marketing world or mass media basically gets 4 hours at this, and the child and the family then basically gets about 10 hours. The interesting thing is we have incredible expectations for those 2 hours that the school gets on an average day. And we need to realize that actually the family and the larger culture have far more control over the time that a child spends than anybody else. What does this brain look like, see? When you take a look at the day, the way a child spends an average day, actually very, very much of that day is spent in social interaction. I mean, when you realize 2 hours a day in school is almost entirely socially oriented, the 10 hours that a person spends with family and friends and by yourself, very, very much of that is in social orientation. And even with the time with the mass media, very, very much of that is looking at other people's faces and watching people move and events go on. And if a child's working on internet, there's all sorts of interactions that are going on. So very much of our time then is spent in social interaction. Now, if we take a look at this brain that is developing in a child, we can begin to see that it's designed then to enhance that sort of thing. And so that one model of this brain that we have is the realization that what we have here is not one brain in our skull, but we have 3 separate and distinct brains. Paul MacLean, who made this discovery about 25, 30 years ago, he didn't know what to call it. He called it the triune brain. He said it's probably the closest thing in human experience to the concept of a trinity, that we have 3 separate and distinct brains in our skull, but they're highly interactive, so very similar to the theological construct of a trinity. But Freud had his id, ego, superego, and transactional analysis as parent, adult, and child, and government has legislative, executive, and judicial. So there is a sort of tendency to organize things in threes in human experience. So if we take a look at this brain that we have, at the lowest level, it's about the size of an index finger. It's called the brain stem, and this would be the lowest level of brain. And the brain stem is responsible for survival machinery. It runs your heart, and it runs your lungs, and all of these sorts of things. It's operative at birth, otherwise you don't live. See, it runs all of these things. This is not the most creative part of your brain, but then you wouldn't want the part of your brain that ran your heart and lungs to do it. waltz time, and, and that sort of thing. Okay, so this part of the brain says basically, will we survive? Now, sitting on top of that, and interestingly enough, it's just about the size of a small bagel with a little chunk out of it that sits on top of it, where this part of the brain says, will we survive? This part of the brain says, well, how do we feel about that? Is that a good idea or not? This is the emotional brain. See, this one is a survival brain. This is the emotional brain. It's called the limbic system. And it's composed of a number of little structures that carry out highly specific functions. Many of these are sort of like thermostat-like structures that as information comes in, they add to the information. And much like a thermostat is when you get the right amount of cold in the room, it triggers the threshold. And at the end, to get from not turning it on to turning it on, it may simply mean that you have to walk through the room with an ice cube in your hand, would be enough to trigger a thermostat in the room. And in many respects, our emotions operate like that. It may well be that one very, very small thing, somebody just looks at you cross-eyed and you explode. See, now it isn't just that did it, but all of the stuff that led before that. So very much like a thermostat structure. And when we take a look then in the second video at this, we'll begin to see how these systems function. These two systems together look inward to our survival, our emotional, and our nurturing needs. So built deep down in this very, very ancient brain here is this construct that we are born helpless, and there's this sort of long childhood, and we have to take care of this child. Otherwise, the species dies. See? We're a social species that is dependent on this. So that take care of yourself, take care of those around you. Who am I and who are these people who are hanging around me is the essential question that this part of our brain deals with. All right, now sitting on top of that, and interestingly, it's about the size of a 12 by 18 sheet of construction paper in terms of its area. Mom Nature, realizing that teachers need readily available audiovisual aids, did that for us. You notice this is a real high-tech operation that we're doing here. But this is 85% of the mass of your brain. It has 6 layers thick. If you take 6 layers of construction paper, that's about 1/8 of an inch thick, and that's the thickness of this part of the brain. It's called the cortex. Cortex means bark. So this is like the bark of the brain. And it sits on top of this like this, or like this on your head. And it's a big sheet of brain, and where this part of your brain looks inward to who I am and who are these people who are around me, this part of my brain looks outward to the space-time challenges of the environment in which we live. Now, if it was like this, that would be nice on rainy days, but we have this skull that would be in the way, and so basically what happens is this part of our brain is wadded around. It looks like a dinner napkin if you open up a skull. It looks like a dinner napkin wadded around here. But actually, it is in here, see, where all of these memories and the strategies and the skills that we have, the knowledge of 6 times 5 is 30, and CAT spells cat, and Washington, D.C. is the capital of the United States, and all of this kind of information, the critical thinking and problem solving that we do. And there's some evidence that is more complicated than that, but that this deals with the space-time natural world that we live in. And that space kind of goes this way, and time kind of goes this way, so that the past is kind of stored back here, and the present, or critical thinking and problem solving, is right in front of your ears, and the part that hangs over your forehead would be where hotel reservations and lesson plans. So it's the past, the present, and the future, and background and foreground, the forest and the trees, synthesis and analysis, so that the space-time world that we live in and that we have to understand then is processed in this world. So this is the inner world, and this is the outer world. Very, very much of what happens in our brain is in response to a sort of an unhurried set of problems that we face. We're moving through life, and there's no real kind of sense in immediacy in the problems that we face. And that what we have to do then is to discover how space works and how time works, and who we are and who those who are around us. And essentially, This is a sort of a continuous exploration that goes on all through childhood and adolescence. I indicated that it was unhurried. David Perkins, in a re-examination of the nature of intelligence, suggests that really what we have to learn through childhood and adolescence is that we have to learn to know our way around various realms in the world.